Hello, on our screen today we have evaluate 2 tan A all over 1 minus 2 tan squared A, and they say that A is equals 30 degrees. So that shows this, we should evaluate 2 tan what? A all over 1 minus tan squared what? A. And they say that A is what? 30 degrees, right? So I don't see the reason why that I was still putting A. They should have said 2 tan 30 degrees to make this something simpler, right? Let's go. I have this could be like evaluate 2 tan, since A is 30 degrees, all over 1 minus tan squared what? 30 degrees. Does it make sense? Now, the next thing we are facing here is what's tan 30 degrees. Now, do you know how to derive the special angles? Now, since the special angle I'm having here is 30 degrees, I can derive the three values of the special angles, 30 degrees and 60 degrees, using an equilateral what? Triangle, an equilateral triangle. So the properties of equilateral triangle, all the sides and angles are what? Equal. So here is 60 degrees, the angles, all the angles are equal. 60 degrees, right? Now, and whereby the length, while deriving the three values of 30 degrees and 60 degrees, the length, we consider the length to be 2, 2. Now imagine a situation whereby a line, we construct a line towards here, a line bisecting this angle and this base. What are we going to form? Three things happens here. So I have these three things happening. So I have, watch out, they form angle 90, because this line now will go here, form angle 90. Now the base, it will divide this thing into two, right? The base is of 2. Now dividing into 2 will make them 1, 1, right? Does it make sense? Here still remain 2, here still remain 2, here still remain 60 degrees, here still remain what? 60 degrees, right? Does it make sense? The next thing, that's the third one that happens, is that the angle here has been what? Divided into 2. So here is what? 30 degrees, here is what? 30 degrees. Do you understand? So if they ask you what's tan 30, now since remember the mnemonic that we normally take in trigonometric ratios. So I have that's the basic one, 1, 2, 3, the basic ones. So tan 30 is actually opposite all over what? Adjacent. Opposite all over adjacent, or tan 60, opposite over adjacent. Tan theta is opposite over adjacent. Tan of an angle, opposite over adjacent. Do you understand? So what's the opposite? Considering 30, my opposite is here, right? And my adjacent is here. Now, considering 30 here, my opposite is the side facing the given angle, still here, and the adjacent is here. Do you understand? Why is my opposite not here? Because here, I'm considering 30 degrees, not 60. So considering 30 degrees, the side that becomes my opposite is the side facing the 30 degrees. Does it make sense? So the next thing, since I want adjacent, I will have to get the value of here. Let's call it y. Now, how do I get the value of here? I can use what is it called? Pythagoras theorem. Knowing fully well that Pythagoras theorem says that hypotenuse squared is equals opposite what? Squared plus what? Adjacent what? Squared. Does it make sense? So the hypotenuse I'm having is 2. So 2 squared is equals, my opposite is what? 1 squared plus the adjacent, which I'm looking for, y squared. So 2 squared is 4 is equals y, 1 squared is 1 plus what? Y squared. So I have 4 plus 1 coming over will be what? Minus 1 is equals y squared. So 4 minus 1 is definitely 3 is equals what? Y squared. So if you really want to get the value of y, you have to what? Square root both sides. So finally, you've gotten that y is equals square root of 3. So you've gotten that the value of here is what? Square root of 3, and the value of here is what? Square root of 3. Do you understand? So tan theta, let me go to the question basically. So when they say 2 tan 30 degrees, it's actually 2 times, what's tan 30? Since tan 30 is equals opposite, tan theta is opposite over adjacent. So my opposite is 1 over the adjacent, square root of 3. So it's actually 2 times 1 over square root of 3 all over 1 minus tan square 30. Now, tan square theta is actually tan theta times tan theta. You understand? If you have sine square theta, it means the same way we have 2 squared is equals 2 times 2. So if you have tan square theta, you have to do tan theta times tan theta. That's multiplying itself. Does it make sense? So if you're having tan square 30, it actually means tan 30 times tan 30. That's square of tan 30. Does it make sense? So tan 30, as we know, is 1 over square root of 3. So over 1 over square root of 3 times 1 over square root of 3. I hope it makes sense. So this is actually 2 times 1 over square root of 3. I'll be having this times this will be 2 over square root of 3, right? Does it make sense? All over 1 minus 1 over square root of 3 times 1 over square root of 3. 1 times 1 is 1 all over 3 times square root of 3 times square root of 3 will give me what? 3. Does it make sense? So I'm having what is 1 minus 1 over 3. It will be definitely 2 over 3. So I have 2 over square root of 3 all over 1 minus 1 over 3. If you can use LCM, that's what you want to do. That's whatever I want to do, do it. But 1 minus 1 over 3 is, if you have 1 minus 1 over 3, 3 minus 1 is 2. So the answer is 2 over 3. If you have 1 minus 5 over 6, 6 minus 5 is what? 1 over the denominator. If you have 2 minus 2 over 3, now what we're actually doing is we remove 1, we minus. So we remove 1, we minus. So I'll remove 1 to remain 1. So 3 minus 2 is what? 1. So I'm having 1 over 3, right? But remember the 1. So the answer is 1 number 1 over 3. Now let's go here. If I have 1 minus 1 over 3, I'll remove 1 to remain 0, right? 3 minus 1 is what? 2 over 3. Does it make sense? So this is actually 2 over square root of 3 divided by 2 over 3. So it will be 2 over square root of 3 times, you invert. Does it make sense? 3 over 2. 2 will cancel 2. So my answer is actually 3 over square root of 3. If you want to rationalize, that's your business. But this is very what? Correct. I hope you understand. So if you see my videos, I beg you, like, comment, share,